All right, powers and exponents. I always like to start off powers and exponents by talking about what multiplication really is. All right, so like for instance, if we look at 3 times 4. All right, we know 3 times, excuse me, we know 3 times 4 is 12. But what does it really mean? Well, we can talk about it in 2 different ways. Basically, this is like saying, okay, 3 groups of 4 or 4 groups of 3. Okay, so let's go about it the first way. 3 groups of 4. So 4, 4, and 4. And if we total all of those, we still get 12. But 3 times 4 is the shortcut for adding or repetitive addition, basically. So multiplication is a shortcut for adding a number over and over and over again, and that's something that we have learned a while ago. All right, so basically what powers and exponents are then is it's a shortcut for, actually, let's go back up here. It's repetitive multiplication. Repetitive multiplication. That's the main definition, or what I want you to think of when you hear powers and exponents. So, taking something and raising it to a power is the same thing as an exponent. All right. So, what are the pieces? Well, we have a base, which is 3, a base number in this particular instance. Sorry, I've moved on. So in this example or this diagram, they're saying base is 3, and that is the factor. Okay, it's going to be a factor. The exponent is up here, and that tells you how many times you're going to use it as a factor. So 3 to the second power does not mean 3 times 2. Common misconception. This actually means 3 times 3, which is 9. Okay, so that is what exponents are. So it tells you how many factors or how many times you're going to multiply that number times itself. All right. Now moving to the middle of the screen here. A couple things that we can say. You can say 3 to the second power, but if anything's to the second power, you can also say that it is squared. So 3 squared can also be used instead of saying 3 to the power of 2 or 3 to the second power. And we also have a name for when a number is raised to the third power. We can say that it is cubed. So for instance, up here, we could say 3 squared. If we had 3 to the third power, we could say, well, 3 times 3 times 3, but we could say that it is 3 cubed if we wanted to. Anything above the third power, we would actually say, like, if it was 3 to the fourth power, it would be just 3 to the fourth power, to the fifth power, to the sixth. So you just use the number and add a th. All right. And where those names came from is if you look at the area of a square, it's if you have a square, the side lengths are all the same. Well, s times s gives you your area of that square, so that's where the term came from. And it's the same thing if you're finding the volume of the cube. It would be s times s times s, or length times width times height. So that's where they came up with those little nicknames. All right. Moving on here to this chart. This just shows you different multiplication powers, basically, or different powers or exponents. So 3 to the first power is 3 on its own. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. And 3 to the fifth is 243. And remember, those exponents will tell you how many times you're going to multiply that number. Some of you may be wondering, looking at this chart, could you have a negative power? You definitely can. We're not going to talk about that quite yet. I'm going to let you think about it, and when we get there, we'll talk about what it means to have a negative exponent, or maybe even what it means to have an exponent of 0. Things that we will get to eventually. All right. All right. So a couple diagrams that can help us here. Let's move that up. the power that's represented by each geometric model. So just for a visualization, think about what's going on here. You're looking for how could I get all the dots, basically? What's the shortcut for that? So it's a 3 by 3, and I can say, okay, 3 times 3, or 3 to the second power. All right, and then letter B. Okay, so now we've got 3 dimensions. So I've got a cube, 4 by 4 by 4, and if I wanted the volume of that thing, or trying to figure out how many cubes there are total, 4 times 4 times 4, or 4 to the third power. All right, and then I'm going to end with a couple examples here, and that'll be it. So I'll simplify each expression. These are numerical expressions where we're just going to come up with an answer. All right, so negative numbers can be involved. Remember, we haven't talked about negative exponents yet, but we'll get there. So you can do this and think about it. Use your rule, basically. So 2 to the third power is 2 times 2 times 2. So what's negative 2 to the third power? Well, that's going to be negative 2 times negative 2 times negative 2. All right? And when we do this, we can, there's a little shortcut I will show you right after this. But think about it in pieces. Negative 2 times negative 2 is going to be positive 4. But then we have to take 4 times negative 2 again. And positive times negative will be negative 8. So this comes out to negative 8. All right. Now, just before we get to the next one, what would 2 to the negative 4th, or negative 2 to the positive 4th look like? So sidebar here. 2, or negative 2 to the 4th. This would look like 4 negative 2's multiplied. Okay? And we just talked about how negative 2 times negative 2 times negative 2, that's negative 8. And then negative 8 times negative 2 would give me a positive 16 for an answer. All right, so here's the shortcut. If you have a negative number and that's your base, and you're raising it to a power, you can look at what kind of power you have. So, for example, 3 is an odd number. And an odd power with a negative base gave us a negative number. Look at the same situation, negative base to the power of 4. This is an even number, and it gave us a positive answer this time. So, for your reference, this can sometimes save you a lot of time. If you have a negative base, and it's raised to an odd power, you're going to get a negative answer. Alright, so I can actually write this out. Negative base so to an odd power will be negative. Okay? To an even power, we'll get a positive answer. So that might be something worth writing down. It can save you a lot of time. Alright, so a negative base to an odd power will give you a negative answer, just like we've proven, and a negative base to an even power will give you a positive answer. And where that's kind of nice is, let's say you had like negative 2 to the 5 or 55th power, okay, something like that. You wouldn't want to go through and try to write out all your negative 2's and take negative 2 times negative 2 times negative 2 55 times. What you can do then is just type 2 to the 55th into your calculator, and since it's an odd number, the power is an odd number, you can get to the, you'll get a negative answer. Sorry, I lost my train of thought there for a second. So you'd get a negative answer for that one. Some students would say, well, why can't I just type this whole thing into my calculator? You definitely could. The one thing you have to be careful of, though, is you want to use the parentheses if they are there. And the reason you want to do that is because if you look at B, which I'm sure some of you were already checking out a little bit, but B says negative 5 to the second power. All right. However, this is not in parentheses like the top one was for A. So we're actually just going to do 5 to the second, which is 25. And the negative is just going to hang out. Okay? So you're only going to include that negative with your power if it's in parentheses, such as letter A was. Okay? The book actually explains it like this. They say, think about this as negative 1 times 5 to the second. You can definitely do that. And this actually would then be, okay, so you've got negative 1 times 25, and then negative 1 times 25 is negative 25. But the way that I like to think about it is, okay, if that negative is not in parentheses, then I'm going to get a negative answer no matter what, because I just have the negative hanging out and the power is not applied to it without parentheses. That's negative 25. Okay, and last example here, 2/3 to the second power. You can think of this in two ways. 2/3 times 2/3, and then just multiply. So 2 times 2, 3 times 3. There we go. That's the answer. The other way you can do that is take a little shortcut and actually just take 2 to the second power. So apply this to this, and 3 to the second power. So 2 to the second over 3 to the second will give you the same thing. So 4 9s. You can think about it that way too. We'll talk about more shortcuts with our powers, and we'll talk about negative powers and things like that in the future. But that's all I have for you today. And if you do want to copy those examples down, you can. I'm not going to make you, but you might want the difference between A and B for sure. So just throwing that out there.